In 8.4, we're going to talk about the binomial theorem. So we'll use the binomial theorem to calculate binomial coefficients, use the coefficients to write binomial expansions, and then use Pascal's triangle to also help us calculate the binomial coefficients. So just a reminder, when we talk about the binomial coefficients, we're talking about when we have some x plus y raised to some power and we expand it. And then those binomial coefficients would be, what this is expanding to and what is the coefficient in front of each term. And so if we go out, we could expand it, but you actually have to multiply it several times. So we're going to kind of go through and look at some different ways to maybe get different terms and how we can use Pascal's triangle to help us with that. So some observations about the expansions. So if we look at the ones that are on this page, x plus y to the sixth tells you that there are n plus 1 terms. So if we're raising it to the sixth power, that means we should have 7 terms. In each expansion, x and y are symmetric. So in your first term is x to the sixth, your last term would be y to the sixth. You have symmetry all the way through. The sum of the powers of each term is n. So in this case, if we're to the 5, if you look at each term, the x to the fourth, y to the 1 equals 5. 3 plus 2 is 5. 2 plus 3 is 5. So your power should always add up to whatever that total degree is. And the coefficients increase and then decrease in the symmetric pattern. So here you have the 1, 5, 10, 10, 5, 1. So we have that symmetry again. And those coefficients are called your binomial coefficients. So to find coefficients of specific terms, what we can do is we can use this formula where we have x plus y to the n. To find the binomial, we do your NCR, which is your n factorial, over n minus 1 factorial times r factorial. And again, this is on your formula sheet. So make sure you find where that is on your formula sheet. You don't necessarily have to have that memorized. Where n is if you look at what n and r are, n is your term that you're trying to find, right? And r is actually the exponent for that second part. So sometimes you see it instead of written as NCR, you'll see it with this set of parentheses, almost like a matrix, where you have n and you have r. So for this first example, for part A, we need to just figure out what the coefficient is of the 8C2. And this would actually end up being your third term in your expansion, because this 2 reflects, again, what that second variable would be. So if the first term is at 0 and the second term it's at 1 and the third term it would be at 2. So if we used our formula, which, remember, going back to the slide, is your n factorial over n minus r factorial times r factorial. So if we plugged that in, we would have 8 factorial over 8 minus 2 factorial times 2 factorial. And so if you simplify this, you would get 8 factorial over 6 factorial times 2 factorial. Well, if you think about what 8 factorial is, that's really 8 times 7 times 6 factorial over 6 factorial times 2 factorial. So those would simplify. 8 times 7 is 56. 2 factorial is 2. So we would get that coefficient of our third term would be 28. And if we do the same thing for B, when it's written in this form, that really just means your 10C3. So we would do 10 factorial over 10 minus 3 factorial times 3 factorial, or 10 factorial over 7 factorial times 3 factorial. And again, if you simplify, this is like 10 times 9 times 8 times 7 factorial over 7 factorial times 3, right? So those 7s, so there's a way that you can really simplify this down. And if you then solve for that, you just get 120. And again, because this is a 3, this means that we're looking at our fourth term if we were to expand, if it was to the 10th power. So if this was like x plus y to the 10th is what we're finding, if it was just x and y, that our fourth term, its coefficient in front would be 120. And so when we look at binomial expansions, if we had to expand x plus 1 cubed, remember this is when we did our preview, this was when we used Pascal's triangle. And we thought about when this is cubed, we're thinking about that row in Pascal's triangle that has the 1, right? Our first 0, and then we have 1 and 1, and then we have 1, 2, and 1, then we have 1, 3, 3, and 1. So this is the row that we're using, the ones with the 3s. And so if we were to use that in our expansion, remember we write out the coefficients of that row. So we would say 1, 3, 3, and 1. And then we would take our x, we would say x cubed, x squared, x to the first, x to the 0. And then we do the same thing with 1, but with the opposite or the backwards exponents. So 1 to the 0, 1 to the 1, 1 to the 2, and 1 to the 3. And then we multiply all of this. So we get x cubed plus 3x squared plus 3x plus 1. And that's how the expansion of x plus 1 cubed would expand, which is a lot quicker than if you were to sit there and FOIL it out the whole time. So sometimes with your binomial expansions, you'll just need to find a specific term in the expansion. And so instead of expanding the whole thing, you're really just using the rule from the binomial theorem that the r plus 1 term is this rule. So if you wanted to find the fifth term, let's say, so if r was 5, we would need to plug in the 4 plus 1. So your r value is always 1 less than the term you want to find. So if we want, looking at example 7, we want to find the sixth term of a plus 2b to the 8th. Remember, we're going to use the formula that NCR times x to the n minus r and y to the r. So if we want to find the sixth term, our r value is going to be 5. It's always 1 less than the term. And our n value is always whatever this degree is up here. So our n will be 8. So to find the sixth term, our a is our x, and our 2b is our y when we're plugging that in. So we'll say 8c5, x, which is a, so we'll have a to the n minus r, so 8 minus 5 is 3, and our y, which is 2b, to the r, which is 5. And then we have to simplify. So remember, when we do 8CR, we have 8 factorial over 8 minus 5 factorial times 5 factorial. And then we'd have times a cubed times 32b to the 5th, since we have to raise 2 to the 5th and 32 to the 5th. And so you end up getting that 8 factorial over 3 factorial times 5 factorial gives you 56. So we have 56. We're going to have to multiply it by 32, and then we'll have a cubed b to the 5th. And so when you simplify that, you get that your sixth term is 1,792 a cubed b to the 5th. So when we look at part B, in part B, they tell us to find the coefficient of the term that's a to the 6th, b to the 5th. So 6 plus 5 we know is 11. So we're looking at this one that's being raised to the 11th. And so we're finding, if this R value right here is 5, we're finding the 6th term. And so if we start the expansion, we'll have 11, our NCR, so 11C5 times 2a to the 6th, we use this first exponent, times negative 5b to the 5th. So when you simplify that 11C5, you get 462. 2a to the 6th is 64a to the 6th. Negative 5b to the 5 is negative 3125 b to the 5. And then we need to multiply the 462, the 64, and the negative 3,125. So we get negative 92,400,000 a to the 6th, b to the 5th. And so the coefficient, because they just ask us to find the coefficient, so the coefficient is just that number out front. So we would say the coefficient is negative 92,400,000. And then this is just that reminder. We've kind of already gone through it. But we can use Pascal's triangle to do binomial expansion, which my guess is that's probably how most of you will go. But you can also use it to find the coefficients of terms that are not in the first few rows. So for this example, if we wanted to find the coefficients of the 8th row of Pascal's, or the 8th row for technically the 7th row of Pascal's triangle, because that first row is your 0 row. So this would be 1, 2, 3, 4, 5, 6, 7. But if you count, that's kind of your 8th row. So you would use your coefficients, that 8C0, 8C1, 8C2, 8C3, and that would give you the coefficients there in that 7th row, which is really the 8th row of Pascal's triangle. Because that 8th row here, right? So if we were to do this, we know that that 8th row, you really could just add these together and get 8, but that is your 8C0. And if you added these together and got 28, that's your 8C1. And if you added these together and got 56, that would be your 8C2. Oh, sorry, this is your 8C1, this is your 8C2, this is your 8C3, because I skipped that 1. When you have the 1, that's your 8C0 row or term.